Hello, in this video I'm going to introduce the concept of function transformations, and I'm going to try to do a thorough treatment of this in a series of videos, this being the first one. So make sure to watch them all if you want examples and everything else. So let's get into it. What are transformations? Well, they come about by adding, subtracting, multiplying, or dividing a function by a constant, basically arithmetic. Those will cause transformations of a graph. For example, adding 5 to any function will always shift the graph up 5 units. Multiplying a function, any function, by -1 will always reflect the function over the x-axis. And there are many others we're going to cover. And the nice thing is the arithmetic behaves the same way on every graph there is, so why not take advantage of that and learn to graph without having to plot points all the time. That's the motivation here. So what we do to graph with transformations is we take a complex looking function with lots of arithmetic, and we'll call that the transformed function, such as y equals 2 times the absolute value of -x minus 4. We can see there's lots of arithmetic there. We also have an absolute value involved. And we start by making it the most basic function we can, determine its fundamental shape. And we call that the parent function. Parent functions are very basic functions typically that we understand really well. In this case, the parent would be the absolute value of x function, which has this V shape. Now this is just, you don't have to understand really any of this. I'm just motivating the concepts. If you're not familiar with the absolute value function, that's okay. Then we use the arithmetic that we see in the transformed function above to start understanding what they do to the graph, what all the arithmetic operations do. And we graph the transformed function by applying those transformations. So let's take a deeper look at this particular example. The parent function for this transformed function was y equals the absolute value of x, which we see here. And then we start breaking down the arithmetic. For example, we see multiplication by 2 in the transformed function. What that will do to every function is it will multiply the y values by 2, meaning it's going to stretch the graph out. It's going to multiply all the y values by 2, making them twice as far from the x-axis, and that's going to give us a vertical stretch by a factor of 2. So I've illustrated that here. Now, inside the absolute value, we see a -4. Now, what that's going to do to the graph is actually add 4 to the x values, which is going to shift the graph to the right 4 units. If you add 4 to every x value, it's going to shift to the right. So we take our previous graph and we slide it, or we translate it to the right 4 units. Last, we see a negative multiplied by the x in the absolute values. What that translates to as a transformation is dividing x by -1. And if you divide x values by -1, you're going to get this reflection over the y-axis. The x values are going to change signs. So it looks something like this. And we get our final graph here, and that is the graph of our transformed function, 2 times the absolute value of -x minus 4. And notice it did not require us to plot points. And the idea is once we get comfortable with transformations, they become really quick because they behave the same all the time. And that's the idea behind transformations of functions.